So I'm Sherry Tibbs. I was one of the team leads for Cyberinfrastructure. I know we're short on time. 2 quick points. I wanted to shout out to Will Brocklesby and his team, James Nesbitt, David Smith, Yasser Bugasa. Awesome people. It was a privilege to get to work with them. And also a quick note to the students. I hope you all realize how much this means to us as team leads. Like, this is the most exciting time of the year for us. It's gratifying and exciting to get to know you. You're fresh, it's fun. Sometimes it's exhilarating and scary at the same time. It's kind of what I would say the work equivalent of getting to spend a day at the water park as this 10 weeks. So thank you. I just want to make sure you all know how much we appreciate working with you guys. So I'll hand it over to my team.
Couldn't see.
Yeah, thank you, Sherry. Thank you for all your help too. And thank you to Will Brocklesby and all our sponsors. Hi, we're the Cyber Infrastructure Management team. Like Sherry said, we were tasked with creating a website that could visualize, query, and update a database containing information on cyber infrastructure equipment, meaning things like routers, switches, cables, and more. And with that being said, let's just get started. So before we jump right in, though, we'd want to provide a brief overview of what we'll be talking about today. So we wanted to start off by addressing our problem and the solution we came up with. Then we'll go over a brief roadmap of the last 10 weeks we spent working. After that, we'll talk about our design iteration and show our demo. And lastly, we'll go over our future steps and take any questions. For that, though, let's meet our team. Hi, I'm Lulu.
Hi, I'm Ezra.
Hey, I'm Christopher.
Hi, I'm Harita.
I'm Nathaniel.
I'm Chico.
Okay, and let's also take a brief moment to thank our project leads, Will and Sherry, and our sponsor, Cisco.
Okay, so imagine that you work in OIT, or the Office of Informational Technologies, and you're responsible for keeping track of and maintaining everything network related. So this can be like cables, wireless access points, and any routers. And you have something in place to keep track of everything that's wireless, but you find that there really isn't any efficient way to catalog any of the physical equipment and all of its like various connections. So you reach out to other companies such as Cisco, and you learn that over there, they're kind of having the same issue and they have yet to develop a solution. So our team has been tasked with coming up to a solution to this very problem as it's faced by Duke OIT. And our stakeholders wanted a site where they could easily catalog, view connections, and access networking equipment. So given these deliverables, we spent the last 10 weeks developing the Cyber Infrastructure Management System. And here's a quick little snippet of our site. So the Cyber Infrastructure Management System is composed of 3 main parts. There's the back end, the front end, and then the API. So the back end is composed of this database, which stores all of the equipment and its information and connections, things of that sort. And then there's the front end, which kind of gives Duke OIT and any other potential users the ability to easily access this data. And then there's the API, which is the connection between the two. So it kind of, if you want to input data using the web interface, it sends it to the database. And then if you want to view any information or request any data, it helps with that as well. So the first few weeks of Code Plus were mostly spent doing trainings and kind of like learning how each piece of equipment sort of worked. This was really important for our project. So we first completed a training, a complete course on networking equipment. And then we also learned technologies such as and Flash to help us with our project. So then we moved on to creating the database, and we used kind of like a made up data. And then we also brainstormed the layout for our web interface, and then the functionality and design and anything else we wanted to be included. So then during weeks 5 through 6, we split up into 2 teams, and that was the API and then the front end. And we continued this way until like the final 2 weeks of the program, where we reconvened to kind of like work on debugging and any other functionality. And we continued to kind of like set rules for how the front end and the back end interacted. And we really worked hard to assess any risk just to make sure that our final project had the highest integrity possible.
Also, understanding the use of the devices which make up the physical layer of our networking model, we went on to design our database, the database schema. But before we did that, we had to understand the relationship between the various devices which make up the networking layer. For example, we had to understand that you could have a switch or a router in a rack which was in a particular room in a particular building, and illustrate the relationship between all of these. To help with this, we created entity relational diagrams. And so to the right, what you see there is one simple draft of the entity relational diagrams, which give us insight into the relationship between the various devices and how to represent them. After doing that, we went on to test our database schema against the information that we had. And so first we came up with mock-up data and then tested our design. And then we went on with real live data and then tested it. After a series of iterations and testing and changes, we realized that our design was indeed able to capture all the information about the devices which make up the physical layer of the networking model.
Next, we just wanted to touch a little bit on the API, which essentially acts as the glue between the front end and the back end. When designing our API, we had 3 main things in mind, the first of which was the functionality. Our database is a CRUD database, which means that it needs to support create, read, update, and delete actions. So when writing our API, we had to make sure that it had endpoints to cover all of these actions. The next thing we had to consider, or that we were keeping in mind, was we wanted our API to be flexible. Our team was using Python to interact with the API, but we wanted to make sure that if in the future this project were to be scaled up, that if a development team wanted to use Rails or Node to interact with their API, that they could. And then finally, the last thing we had in mind when designing our API was the usability. Like Ezra said earlier, we split into 2 teams, the front end and the back end. And the back end team wanted to make it as easy as possible for the front end team to interact with our API. So we made some classes. And essentially what these classes did was encapsulate all the information about certain objects. For example, racks, you might have like how tall it is, what sorts of what is the form factor, and like what types of holes it has. And then that class would provide the front end with some methods that they could easily post information back to the back end or update existing racks, stuff like that. And it was also used for validation.
Okay, so I'll talk about the front end. So the front end is the interface which allows a user to interact with our system. So the picture you're seeing now is the first design of our front end. So the picture to the left was the landing page, and the landing page had all the functionalities as button. So as you can see, we have the add, update, and locate. And then if you click on any of these buttons, you're given a font like the picture shown on the right. So the fonts will depend on the equipment you want to add, update, or locate. And the user will be required to enter the necessary information, which will be sent to the API. However, we realized this wasn't so helpful. Imagine having to enter all the information about an equipment if you want to update, locate, or add or anything. So we came back together as a group to discuss how we can make a better design. So the picture you're currently seeing was a draft of our second design. And then the picture to the left was the landing page. So we added the overview, the demo FAQ to orient a user about our system before he or she signs in. And when you sign in, you will access, you see the information about all the equipment when you click on any of the equipment. So as you can see from this picture on the right, the information about all the equipment is shown, so the user wouldn't need to enter all the information to see an equipment or to locate an equipment. And then next to each equipment, we have all the functionalities as buttons, so the user can access any of these functionalities without necessarily typing in all the information about the equipment. Our video will show more about what I'm talking about.
Hi everyone, I'm here to give a demonstration of the Duke CIMS web app. When a user visits the website, the first thing they see is the landing page, detailing attributes like features of the web app, a link to view a demo, a link to the documentation detailing how to interact with our APIs externally. This links to an external page, and a help section, which has a contact option and also an FAQ section. So everything I've shown you up until this point can be accessed by any unauthorized user, but you'd have to sign in to get into the main part of the application, which gives you access to manipulate the data. When you click sign in, you are redirected to Duke's Shibboleth login, where you authenticate with your NetID, and if successful, access is granted. Now, since I signed in earlier, clicking the button just takes me directly to the app. And after you sign in, you see this main part of our application. If you look to the left, we have all the entities whose connections we are trying to model. So let's click on the building entity. Now, looking at an entity like building, we have various descriptions like name, address, and options to make changes to our database like edit, update, and also delete. And you can also sort. So if I want to sort like the ID in descending order, I can just sort. Same thing goes with name, building number, and every other column name. Now, looking at an entity like building, it might seem like entering data is fairly simple. During the design process, however, we realized that a lot of entities had some kind of dependence on others. Now take racks, for example. If I come to this page and simply display a list of rack names without including more information, like where they are located, so like the building and the room, it's practically useless because there's no way to know what I'm talking about. And with that in mind, we implemented a solution that allows users to filter data that are dependent on one or more entities in order to streamline queries and get specific results. So what exactly do I mean? So let's say I want to see all the racks in the telecom room in the ATC Strickland building. I just have to filter with this like drop down list, and then it just filters my table for me, and I'm able to see the specific data that I want to see. So let's try something else. Let's say I want to see all the racks in the equipment room in the chemistry building. I can just do the same thing, and it just filters it for me.
Now I'll hand it over to Lulu to shed more light on the functionalities.
Okay, now we'll talk more on the functionality of our website. So we'll talk about the details, editing, updating, deleting, and adding things to our database. So the first thing I wanted to talk about was the details pop-up. So if you wanted to see further information on any of the pieces of information in the database, you could click details, and for now it displays the building name, but you could always customize that depending on anything more that you'd want to see. Another thing you can do is edit and update the information in the database. So for instance, if you wanted to edit the information in the chemistry building, we could change the building number to 1255 and then press submit. And we should see that there is a change in the database based on what we just did. And yep, it changed the building number to 1255, so that's good. Another thing we can do is delete things from our database. So for instance, if the Fitzpatrick Center shuts down or something, we could always delete it. So if we press delete, a confirmation pop-up displays, and if we really want to delete it, we can press delete row, and it should leave our database. So as you can see, it is now gone. And then the last thing we wanted to display was adding things to our database. So let's show that with network nodes. So you press the button add network node, and it'll take you to another page where you can select from these drop downs where you want to add it to, just so that it has more applicability, so you know where the network node will be placed. So let's say it's an ATC Strickland in the telecom room in rack 7, and the room in the rack will change depending on which building or what you chose before that. And so let's say that it is a router with the management IP address that on position 10, and let's label it test switch. Okay, let's add that into our database. Yep, and as you can see, it added it in right here. Now let's go through an example where adding it in doesn't work because of our validation checks. So for instance, if we wanted to add in the same rack 7, with an IP address that is not the correct format and in the same position that we just added in our last model or our last router, and the label can be "this switch is wrong," what we should see is that it won't add it in because we did checks on whether the management IP address is the correct format, and also that the position on the rack is not already occupied, just so that the data makes sense, because it wouldn't make sense to add another network node where a router already is on that position on the rack. So yeah, that concludes the demo of our website.
Hi everyone. I'm here to give you them. Hi everyone. I'm here.
Hopefully our demo was able to give you a fundamental understanding of the design of our web app and its functionality. I'll then move on to talk about the future steps. The first thing we want to do going forward is to improve the data visualization. As was seen, the current structure has it that everything is displayed as tables, but we're looking forward to having it displayed using 2D or 3D images, so that you'll be able to visualize whatever is happening there and then the connection between the various equipment. In addition to that, we also want to add activity statuses to the devices, so that probably a green would show that a device is active and a red would show that a device is not working. We're also thinking of syncing the data that we have with the Duke facility, so that in case there's a change to the information that we have, it will be automatically updated into our database there. We're also thinking of adding an automatic a catalog, which is supposed to keep track of all the changes that have been made by the various workers at the IT department. So in case someone makes any change, we'll be able to see who did it and when that was done. The final thing we're thinking about is a mobile version for the data entry and validation, because we believe that this will make our data entry easier. So in summary, what we did as a team was first of all create a database which would collect all the information about the devices which make up the physical layer of the networking OSI model. Then we went ahead and split into two groups. One which worked on the front end, that is the platform which you interact with, the user will interact with, and then the API, which is the link between the database and the front end. I would like to conclude by thanking our sponsors, Cisco, specifically Asasif, Tony, and Jason for their tremendous help and feedback. I also like to thank Jen and Isabel and their project leads, Will and then Sherry. And I also like to thank Miriam as well. And on that note, we are open for questions.
I think there's something in the chat. Is this going to be something just used by Duke OIT, or is it something you've talked to other companies about using?
So, Chika, you can go ahead if you want to.
Oh no, it's fine. You can do it.
All right. As it is right now, it's definitely tailored towards Duke. We have like shibboleth logins integrated, stuff like that. But I think in our design process, we definitely we're thinking about how we could make this so that it could scale to other places. But yeah, as is right now, just Duke OIT.
Hi, everyone. This is Will Brocklesby. I'm one of the project leads for this group. And I just wanted to say, I think the team did a phenomenal job with this project. And while it was certainly developed sort of with the vision of Duke OIT in mind, we could see this potentially being used within other portions of the university, like potentially DHTS. And then, with some continued development, we could possibly share this, with other members of the higher education community as well. So I think the team, I just wanted to echo again all of the great work that they did that Sherry mentioned earlier, right? In terms of not only developing the application, but having to come up to speed with so many aspects of networking. That was sort of a daunting task to get over that. And it was amazing to see everyone come together, learn all of the sort of characteristics of physical networking, and then develop database models, and then even, go beyond that and build the application on top of it. So I just wanted to say thanks to everyone for this awesome work.